course, Cobal, of course.
No, but I joined more or less at the same time that Koba.
So, allora,
Me, no. I'm very old in general. Yes.
in inglese.
I joined in
So,
2014 or 15.
hello everyone. Thank you for joining
Yeah.
Jug Milano meeting 142. So a big round of applause for the venue, the speaker of tonight, and for your welcome here. Applause, please. And for the people that are following with the streams, please, if you can, you're always invited to join. Just a couple of logistic things before I leave the word to Luca and then Carlo for the speakers of tonight. So, as always, please subscribe to the Jug Milano mailing list and YouTube channel. As you know, they are the two most important channels that we use to communicate for the next event. We are always looking for speakers. So, as you can see, we have really a diverse set of topics that we try to speak about. So please don't feel shy if you have found something at work while doing something at work or in your free time that you think it's of interest for anything not strictly related to Java, but the JVM and everything that is revolving, say, even cloud native platform that is playing with Java nice nowadays. Feel free to submit a proposal and, of course, to participate. I would like to give a special thanks to eDreams Odigeo, who is kindly hosting us, and now Luca will speak about it. And special thanks as well to IntelliJ, that is always putting a raffle for one license. And with that, I will leave it to Luca. Thank you, Luca.
Okay, thank you, Matteo. And well, on top of IntelliJ, by checking in, also you will participate on a raffle Prime membership for eDreams. For eDreams, and so it's another things that we put on top in all our meetup we host. Okay, so I know some faces here from the last meetup. Well, eDreams, it's maybe known in Italy as a travel website, travel e-commerce, but actually behind eDreams we are a community of more than 600 developers. And now today we have the pleasure to have Carlos, our chief architect, that will explain a topic well quite new in the technology, also in the industry. Whatever, if you are up for a challenge, we are looking for developers, so you can find some QR code in the walls, or if you have any question, you can ask to me or anything that you see with the line art. For more information, we can tell you everything. Okay, so I just leave the word to Carlos and.
So, thank you. Thank you very much for coming here. I have to apologize twice. First, I'm sorry I cannot do this in Italian. I will have to do it in Inglese. Second, I have a sore throat, so my voice sounds uh, not very nice, and maybe I break during the event. But don't worry, I will survive. So then, thank you for coming. Basically, I'm going to talk about microservices and data. How the transition to microservices changed and impacted how we treat data in eDreams. Basically, the overview of the whole talk is I will do a brief explanation of what is eDreams in terms of the technology and the platform, so you understand the context of the problems that I'm going to describe. And then the talk has three parts. In the first part, I will focus on the online platform, on the Java, the microservices world, and how data impacted, how data was impacted when we moved from a monolith and a few services to the current over 200 microservice platform that we have, and why we move to domain events and something we call snapshots to exchange data as the preferred kind of data exchange. The second part is about the analytical world, so BI, data science, how microservices impacted the way they consume data and the way the online platform exchanges data with them. We will explain the problems, then I will explain what until a few couple of years ago was the way to do this, which was data lakes. And I will also explain why we were not very keen to adopt data lakes, how we stumbled into a blog entry in the Martin Fowler's blog about data mesh, which is an alternative to data lakes. I will try to explain very briefly what is the paradigm of the data mesh and how is it different to a data lake, and what is the way that we implemented the paradigm, how we do started the data mesh. And I will finish with things that we have now in the backlog that we want to do in the near future. Okay, so the context. eDreams, yes, we're a travel agency. Just to give you some context, we are the second largest seller of flights in the world. The first one is in China. I think that this is tricky to beat, but we have our ambitions. It's a 24/7 e-commerce. It's from a functional point of view quite complex, and we have very considerable amounts of traffic. We have peaks of over 100 million searchers per day. We serve the same platform, exactly the same, serves 5 different brands in over 40 countries with multiple languages, multiple currencies. In Italy, it's eDreams, the best known brand. In Spain also, but in France it's Go Voyage. In UK and Germany it's Opodo. But it's always the same platform for everything, even if it looks very differently. In terms of the architecture, we have now almost 300 microservices. We structure that in I think exactly 35 domains. We have now more than 400 developers. This is a bit outdated. In over 50 teams. We have multiple development centers. The main ones are in Barcelona, Madrid, Porto, and this one in Milano. And on average, we do 60 releases of the microservices each single day, with peaks on over 100. Where in terms of purely infrastructure, we are on cloud. We use Kubernetes, and we have peaks of almost 30,000 CPU cores. We are a very data-driven company, and it can be shown, and we have a good data science team. We do almost 2,000 million machine learning predictions every single day, and we do around 1,000 A/B tests every year. So we're not Google. We're not a little startup either. We're something, I would say, in the middle. And one thing that's important is that you may think that an online travel agency is something from a complexity point of view simple, but it's not. There's people working in fraud or in payments, working with credit card companies that have absolutely no idea how the flight world works, or people working in hotels that don't know anything about flights, people in flights that work with airlines that do not know how these flights are actually pushed to customers. So it's normal. Nobody in eDreams knows how the platform works, really. Some people know the little corner of the world. Others, like me, know the big picture, but then I get lost in the details. It's complex enough so that this is actually quite the challenge. And this leads me to the first part of the talk, which is about the online platform itself. Why we moved to microservices, I don't know, 7 years ago, more than that, before it was called microservices, and how that has impacted data. So in the beginning, we had a monolith. Actually, we had a sequence of monoliths because the company was founded in the late 90s. And from the data point of view, a monolith, it's heaven. It's heaven. There's no doubt about this. Why? Because first, if you want to know what data you have in the company, you go to the schema in the database, and it's there. You can list your tables, the columns, everything is there. If you want to cross-reference data, you do a join in SQL, and it's simple. Data integrity, no problem. The database has integrity rules, foreign keys, check constraints, everything is covered. Sharing data, again, with reporting, with data science, no problem whatsoever. It's very easy to configure your database to have a read-only copy in almost real time. We did this, works magically, everyone is happy. With this, no impact in operations, and everybody has exactly the same data as in operation, no errors whatsoever. Access control, again, super easy. There's only one database. Who owns the data? Quite easy also, because there's only one repository with the code. So if you want to know who's writing to this table, you go to the code, do a little search, and you have it. So it's heaven. Unfortunately, it comes with a price. which is basically that you have a bottleneck in the release pipeline. Many years ago, when we had this, we had metrics, and at the time, we never got over a few, 2, 3 releases per day. That was the best that we could achieve. And this is a problem, and we did things. Right? We did things to try to optimize this. I think that in that time, it was quite an achievement that we did more than one per day, to be honest. We did canary releases already, and we use feature toggles to try to parallelize and to unblock things. But still, it is a hard limit. If you want to grow your company among a certain level, what's the use of doubling the number of developers if all of them are blocked waiting for a release? Because remember, in a monolith, all the features that you write go with the same release. If something fails, you roll back everything, and now everything is blocked until you fix and you go back again. So the monolith is a hard limit on how much you can scale your company, how many developers can you have working in parallel. And that's the only reason that we actually did a huge investment to move to microservices. And here I put some numbers. The value of microservices that they enable having parallel development, and they enable growing the number of developers and the throughput you can achieve. And here in 2008, we had around 20 developers. We had a monolith, no data science, no machine learning, and we did 1 release per day on average. 2015, things had already changed. We had over 150 developers in 11 teams. As you can see, we already had a monolith with some auxiliary services, and we managed to do around 10 releases per day. But still, at that time, we had something called the release management team, which was a team that took care of seeing what were the release requests, understanding the commits in those releases, and try to think, okay, is this going to fit? And if that was the case, then you were allowed to release. So you had to have coordination in the releases. This is now over. In 2022, we had over 300 developers in over 50 teams. We had over 250 microservices, 10% of which were machine learning services, and we achieved 60 on average releases with peaks of 100 per day. And the important part here is that they were not coordinated. In eDreams, there are some people from eDreams here. If you want to release, you release. You don't even think of who else is releasing in the platform. You just do it, and magically, it works. This is the beauty of microservices for us. Unfortunately, on the data side and on the online on the online platform, this comes with again a price, because with microservices, it's forbidden that microservices access the data of a different microservice. The databases are isolated. So when you want to exchange data, you can no longer just query and join. You only have 2 options there. Either you can ask the other microservice for the data, or the other microservice can push it to you and you consume it. And which way is better depends on many things. Some are technical, but some are, I'm going to try to convince you in the next minutes, that some depend on how big your organization is, how many developers you have, and how many microservices and things you have. And one learning we have is that the better you get at parallelizing development, so the better your microservice architecture is, the worse your data problems become. And and now I will show you that as we grew over the years, we experimented with several ways of exchanging data, and we'll go through all of them. And today, actually, we use all of them in combination. It's only that we have different rules of when one or the other is better. So the first pattern here, it doesn't get more simpler than this. If a microservice wants to ask another for data, you just query it. You create a new method in your API, and you say, hey, give me some data. Here you have a simplified, I'm going to show examples. All of them are simplified, because otherwise this will be extremely boring, but are real in the problems and in the business context. So one example that we have was many years ago, we had the booking engine, which was the service that actually did the booking of a flight. And we have a different team with a different service, which was the landing pages. Landing pages is HTML, SEO, SEM pages. If you look, if you Google now for eDreams flights Barcelona Milano, and you click on our page, you will see a page. There's a service that generates all these pages in batch or real time. For that, the team needed to know which were the more popular routes, and that is only known by the booking engine that actually closes the routes. So the team asked the other team, create an endpoint and tell me which are the most popular routes. This works. It's effort in terms of effort and development is super simple, but it comes with several problems. First one is exactly what does it mean a popular route? Is the one that we sell the most? Is the one that we make more money? Is the one that people search the most? Because those two things are very different. Of course, the only ones that really know the answer are the people in the landing pages team. But of course, maybe they want to change or experiment with different definitions. But for that, every time they want to do an experiment, they need to ask the other team that has its own problems to implement a new version. Of course, when you're very small, this works. As you grow bigger and bigger, this starts not working very well, particularly because the people that developed the original query no longer are in the team. And that means also that with time, the people that are doing the maintenance of the booking engine have an endpoint there with some unit tests, but they don't really know what this is for. So how do you test something, a code that you don't really know what's the purpose or who is using it? The normal thing is that this deteriorates without anybody knowing, because the ones that implement it don't know what it's being used for, and the ones that use it don't know how it's implemented. So with time, this tends to, even if you have unit tests, to work badly. It's not what you intended, and blocks the people that use it from experimenting with new things. One advantage that you have in this case is that the landing pages team is decoupled from the model of the booking, which is a very good, because at the end you only need a list of routes. So in end, to summarize, you have very low autonomy of the people doing the query. You have risks in terms of data quality, and you also have risk in availability, because what happens, the people in landing pages, what happens is now they do a loop and they multiply by 10 the number of queries that they do. Maybe they have an impact in the booking engine that is not optimized for that number of queries. Few years later, in 2013, we have another example, which is sometimes, even if the owner of the data is willing to do an endpoint for you, that's not good enough for you, because maybe the underlying data system that they use cannot give you what you want. An example was customer service. At some point, the customer service team wanted to have a way of doing a text search in our booking database, like the Google search. Of course, the database of the booking engine is transactional, and transactional databases don't implement this nicely and at scale. The ideal thing is to use something like Elasticsearch. So what did we do? Well, okay, we created a new service, which was the booking indexer, and the team asked the favor of the booking engine guys, again, every time you update a booking, please tell me and send me the whole booking. And then the service stored the booking in its own system, which was Elasticsearch, and expose a find by text API to the customer service. And this actually worked very well. It has some problems. One is that, of course, because the push that happens is directly from between booking engine and the booking indexer. If the booking indexer is down for whatever reason, maybe maintenance, whatever, then some updates are lost. Good thing is that there was independence. The booking model of the booking engine was not exposed to customer service. It was only exposed to booking indexer, which was good. And of course, you could optimize the storage of the find by text. This worked very, very well. So well, in fact, that with time, other teams in different domains started using the booking indexer for their own needs. And this created a risk that actually materialized sometimes, which is that sometimes the booking indexer had problems operationally because too many people were doing too many queries, because it was shared by too many people. Later in time, let's go to 2016, a different kind of problem, which is that sometimes you want to query data and your microservices have grown so big that the data is not in one single one. You need many of them. Here, an example we have with BI, as I explained long ago. BI exchanged data with the platform by replicating the making read-only copies. But at some point, this is not possible or not advisable. So instead, we created a service that collected data from different microservices and pushed it to a database organized for BI. This is the booking reporter here. And here, the problem is that you need to collect data from multiple places. And we did a mixture of two things. First, the booking engine no longer pushes the data directly to the service, but instead publishes the updates to a Kafka queue. And then, for other services in different domains, the booking reporter actively did joins by querying by ID the foreign keys of the booking engine to these services. Again, this works quite well. You have low coupling and high autonomy, but there are some problems. First, you still have some operational risks because the booking reporter is actually querying with a get by ID to other services. It's true that the get by ID is not a method, it's not an API that is a favor to somebody's a core API of the systems, so it should be quite optimized, so the risk is a bit less. The biggest problem with this is that the booking engine team has very little incentives to care about the data quality, because at the end there's nothing in there for them. If they have a bug and they lose some messages, they don't care. They don't even realize. They don't really measure this because it's again a favor that they do to others. And this was the main. This is the main problem with this pattern. So, to summarize, what we learned with all this is that the query pattern is perfect, is simple, but only when the query methods that you're using are not a favor that the team is doing to somebody else. It's something that is part of the mission of the service. So the get by ID is part of the mission of the service. The find popular routes had nothing to do with what booking engine does or understands. As long as the querying is part of the mission of the service, everything is good. The code is simpler, is very simple. It can even decrease the amount of coupling, because if the output of the query is not the data model but some aggregation, you're actually isolating the client from the data model. Whereas the push model, you have to couple yourself to the data model. When they update something, you have to update. But when these conditions do not match, when the querying is not part of the mission of the service, it's much better to have the producer of data just push data to the outside world and let consumers use it. This scales better because one nice thing is that you will always have more consumers than producers, always. So if you want to scale, you have to lean on the consumers. It's consumers that we chose that every time that we can, we design things so the burden of exchanging data is on consumers. Why? Because there are more consumers than producers. And the ones that actually care about the data are the consumers, not the producers. And the other thing that we learn is that the less data you share, the better. Because remember, when you push data to the outside world, you are getting coupled to all your consumers. If you want to change the data that you're pushing, you have to synchronize with everybody. Even if you do versioning, at some point you will want to retire the old version. And you will not be able to do that until all your consumers have upgraded. So, some years ago, we decided that when you put all those together, we decided that we would use domain events as a key ingredient. If in case some of you are not familiar now with the concept of the event, this is, as I say, standard. The main event is a representation of a fact, something that really happened in a particular domain in your company. This is standard. we added a few controversial things. But in summary, it's a fact, and one way you can make sure that it's a fact and not a command, because sometimes people confuse if I push something to a queue, to a topic in Kafka, that's an event. Not necessarily. Maybe you push a message that it's a command, it's an order. Do this, do that, and it will happen asynchronously. That's asynchronous, it's a message, but it's not an event. The event is the presentation of something that actually happened somewhere. And to make sure that we follow that rule, we have the convention that all our domain events need to have a name that ends in a verb in the past tense, like booking confirmed, or booking cancelled, or booking requested, or something like that. Another rule that we have is that we do not allow that a domain event is published by more than one microservice. If there's a domain event in our platform, there's only one microservice that is publishing it. Why? Because that's the only way that you can ensure that you have ownership. You know that if there's something wrong with that event, that service and that team are the ones accountable. Another is that to have integrity, all our events have a explicit schema that is version, and when we publish events, we make sure that the event fulfills the schema contract. Another thing is that to make easier to interoperate, we have a common set of metadata in each event. Things like the ID of the event, the timestamp of the event, the service that publishes the event, the version of the schema. All these are always in all the events. Another rule is that there's a single source of truth, meaning that we do not allow a service to publish data that is not data that it generates. If you get data from another service that is related to the event that you want to push, you cannot put it there. Of course, you need to link things, but for that you only need to put the ID, the foreign key, let's say, of the data of the other service. And we only make one exception, that is sometimes if you want to make a reference to an entity of another service, and it's important to you that that entity is mutable, so it can change with time, and it's not versioned, and it's important to your event to describe what was the state of that entity at the time of the event, then we allow you to do like a little summary of what the state was relevant. And then the other rule, and this is the most contentious rule that we have, is that we do not allow to put any data in the event that is not strictly associated to the event itself. For instance, in the case of a booking cancelled, it's reasonable to put in the event all the data of the booking. We do not allow this. The only thing that you can put there is the idea of the booking that you're canceling and reasons about the cancellation. You cannot put anything there about the booking itself, like for instance the route. That belongs in a different event. Why? Because remember that we said that we want to minimize the amount of data you exchange. If you do this, people that are only concerned about cancellations, maybe a number, will not couple themselves to the structure of the booking, which means that if the booking changes, this event will not change. And this happens again and again when we design new domain events. You always have the temptation to enrich the domain event with things that you already have, data that you already have in your code, to make life easier for the consumer. But we have the rule of don't do it. The consumer, if they need more data, they can join events together asynchronously, but keep your events as small as possible. And believe me, this temptation happens every single day. Again, I have here people smiling from eDreams, and we try to resist the temptation very, very strongly. A few words then about how we implement this in Java. At the end, you are all Java developers, I guess. For the streaming platform, we use Apache Kafka. In Apache Kafka, as you probably know, there's no guarantees of order when you read, unless you do something special. What we do is that we make sure that we have only one topic per aggregate, so all the domain events of a single aggregate like booking go in the same topic, and we use the idea of the aggregate to partition the queue. So when you read, you will always read the events of that aggregate in the order that they happen. We use Avro for serialization. We chose Avro because it's quite common and allows you to define schemas explicitly and allows you to document your schemas in the same schema file. And We use a Maven plugin to generate automatically the serialization and deserialization code from the average schema. We also, as part of our build, we have a convention. All the domain events of a given module are in a separate repository with a name. So if you want to know, if a developer wants to know all the events of another module, it's very easy to find them. In that repository, you can find all the schemas, so you can check the documentation. And if you want to use it, you only need to import a jar file, because the build system will automatically package all the schemas, generate all the code to serialize, deserialize, publish and not publish, and put it in the jar. And then to ensure that we have all of them have the shared metadata, we have a common library that takes care of making sure that the metadata is always there and it's correct. It takes care of publishing the events, so you don't need to worry about how Kafka works. And it has an extra feature, which is that Kafka, as you may know, is not transactional. And sometimes the events need to be transactional. For instance, you don't want to publish that a booking has been cancelled and send an email to somebody if the cancellation, the transaction rolls back. You don't want to refund the same booking twice if you try and then retry. So that our library, what it does is that when you want transactionality, instead of sending the event at the moment that you tell him to, will actually do an insert in the database in the same transaction as the of the global transaction. If the transaction succeeds, you will commit the insert and the event will be sent asynchronously. If the transaction rolls back, then no event is sent. So with domain events, the example that I gave about how the landing pages, how does it look like? How did we change the landing pages system with this? Basically now the booking engine does not have the find popular routes. Instead, it publishes domain events of things that happen. In particular, you only need two for the landing pages. You need the event when a booking has been created, and another event which will contain the information about the route, and the event of when a booking has been confirmed. So it's solved without problems. With these only two events, the landing pages now can have its own database with counters, and this database is way simpler than the database of the bookings, because the only thing that it needs to know is the things like the route that define and the counters defining the popularity, and they are free to choose whatever definition of popularity they want. They're even free to choose whatever definition of route they want, because what is a route really? Is it a couple of cities? Is it a couple of airports? Is it a couple of regions? Because sometimes people look for a flight to Italy, not to a particular city. And because it's only counters, this can be done extremely efficiently, much more than they did it in the past, much more than with the query. And for booking engine, this is perfect because they have no operational risks, no strange queries, no tests doing of an API that they don't understand. There's a problem with domain events, however, which is that in some cases, like the customer service case that I explained before, there are some clients of data that they do not want to know the things that happen to the state of your entity, like the booking. They really want to know what is the final state, and the reasons why the state changes are irrelevant. The customer service example is a good one, because at the end, the tools that our agents use to answer the calls need to know what is the latest state of the booking. The sequence of events that happen is not that important. And if we only use domain events, and we force the customer service people to use domain events, we're actually increasing the coupling, because first, you would need to define a domain event for every single thing that can happen with a booking. This is a lot. And worse than that, it would force the customer service developers to understand what the domain event means, because they have their own model simplified of a booking. But to reconstruct that by listening to domain events, you need to understand that a booking cancel means that you have to update this flag. And there are, if you define 150 domain events for a booking, this is much worse than we had before. The coupling is worse, and the dependency between the teams is much worse. So, for this kind of cases, when the client wants to have their own parallel model of another entity, we conceive this the concept of snapshots. A snapshot is a stream of states of an aggregate. And it happens asynchronously. So if you only want to know the latest state, you can subscribe to this stream of states and just listen and do whatever you want with that. You can consume in our presentation, you can consume snapshots asynchronously, which is the usual way, or even if you want synchronously also. And when we implemented this, in our case, we found a big challenge because the first thing that comes to mind when you want to implement this is using AOP, because you can intercept all the writes, all the updates, and then push data out. The problem is that in many cases, when you have a bug in production and that bug has created wrong data, yes, you fix the bug, but now you have to fix the data as well. And yes, you can do that in Java, but it's a lot of work. It's usually way more efficient and fast to fix the data. If you fix the bug in Java, and then you fix the data with a SQL script and a few updates. And we do this very often. But because we do this, the AOP aspect-oriented programming way of doing things is not good enough, because it will never tell you when somebody is changing the data with a SQL script, because you're not intercepting that. So the only way that we have to do this in a robust way is to use CDC, change data capture, which is something that you connect to a database, and it's the database that tells you what are the changes. The problem with CDC is that because it works at the database level, table and row level, if you use it, whoever is consuming that data is completely coupled to the internal data model, which is something that you want to avoid with microservices. So the challenge here was, how can you use CDC for this without coupling everybody to the internal representation of the database of all other microservices? So then this is what we did. This the overall architecture. Basically, you have a producer of data in orange, and we have all the microservices that listen to the snapshots in blue on the right, and we have two generic services that are the same for all the snapshots that we can have in the company. That the way they work is that if you want to have a snapshot, the producer only needs to do two things. First, you need to enable CDC in your database, and second, you need to fulfill an API REST contract, which is defined by the snapshot people. Which basically, this contract has only two methods. One is I give you the ID of your aggregate, and you give me the photograph, the actual state of the aggregate. Is one thing, easy, with an average schema, contact, like the main events. And the other thing is I give you a row ID of one of your tables, and I give you the name of the table, and you tell me the ID of the aggregate of that table. Because in normal cases, aggregates are not stored in one single table. They may have 2, 3, 15, 20 tables. And not all transactions actually change the master table, the table with the primary key. Sometimes they change a child of a child of a child of a table. So the challenge here is, okay, if your transaction changes a child of a child, how do I know the ID of the aggregate that I need to do the snapshot? So the only thing that the producer needs to do is, when I tell you the row ID and a table, you tell me the ID of the master table. And with this, the way this works is that the CDC system creates a stream of changes of rows and tables. There's a system that will read that in real time and publish a message in a Kafka queue. And then there's the snapshot publisher, which is the system that will read that. It knows the service, it knows the table, so it can first ask the producer, hey, tell me the ID of this row and table that have changed. And with that, it will do a second call saying, hey, give me the snapshot of this. And with this, it will publish in Kafka the ID and the snapshot, which is what all the consumers consume. And with this, we solve the problem of parallel models, because now, if you want to have a parallel model of another system, you only need to ask the source system to use the snapshots, and that's it. And in this way, we achieve to use CDC without coupling anyone to the internal representation, because the internal representation of your tables does not ever leave your system. Nobody needs to know. Okay, with this, I close the chapter on the online platform, and we get to the analytical side of things. So how do microservices impact the data that people in BI or data science use? and what are data lakes and why did we didn't choose data lakes. So again, data has a life beyond the online platform. BI and data science are examples. Another example is the monitoring teams. We have teams that do monitoring of the platform, and they are also users of our data. All these teams had a way easier life with the monolith. Why? Because now they have dozens of schemas. They don't know how to find what data we have. When they find it, it's not easy to know who is the owner of that data. The old way of replicating things does no longer work, because developers do not know that the data is being replicated, so they can rename a column and then your whole system is broken. They cannot, in general, do joins because the databases are isolated and you cannot join data. And there are no integrity constraints across microservices. So there's potentially less data quality. Of course, life has a way of finding a way of solving problems. So what happened in eDreams, and I think in all the companies that have gone through this journey, is that basically each analytical data team pushed and created its own data pipeline to extract the data they needed from the platform. And because each of them did this in a different way, you end up with different data pipelines and different data silos. The BI people have their own data pipeline, the data science have their own, the customer service, the analysts of customer service have their own, and this comes with several problems. First, the producers of data are not happy because they have to implement these data pipelines again and again and again. The same today, this morning, I had a complaint from a colleague here in Milano that they don't want to spend a lot of development time exchanging the data with multiple data pipelines. Also, analysts are not super happy because there's inconsistencies here. When they compare data from one silo to the next, it's not the same. There's always little inconsistencies. And when you introduce data science in your company, this gets even worse because more or less the people in the silos are happy with their little silo. But data science has this ambition of matching data of the whole company, because you never know what correlations are out there. And you want to use machine learning for everything potentially. So they really want one single data system and not a variety of silos. So some years ago, we said, okay, what can we do about all these problems? And in 2019, which is when we did this, the solution was the data lake. There was if you looked in the books and conferences, this was the solution. And basically, data lake is a single repository of data where you can have data from multiple sources in this raw original form. You can have transactional data, you can have XML files, PDFs, whatever. But something very curious happened, which is that if you go to Wikipedia, in the same article that defines data lake, you have the definition of a data swamp, which is a place where data is unusable. Nobody knows how does it work. The quality is bad, and we thought it's very peculiar that first it has a name, and second that the name is in the definition in the Wikipedia. This is a smell that something is wrong with data lake, or something at least is very risky about data lakes, and it's not easy to have a data lake, and that most people that start building a data lake end up with a data swamp. This was a bit scary, to be honest. So we asked some consultants of big firms that had done data lakes with success, or so they told us. How can we do this so we don't have a data swamp? And in summary, they said it's all about data governance. You need strong data governance, and you need to design the data model for your whole company that it's good. And you will need a central team, data team, that is in charge of ingesting the data from all the company, ensuring that the data is good, and enforcing data governance. And I really believe that this works in some companies. In our case, we didn't think this would ever work, basically because it has a conceptual contradiction with the whole domain microservice autonomous teams. Because how is it possible that we create a single team that has all the functional knowledge in the company that today nobody has, to make sure that the data model of the data lake makes sense. And if you cannot have that knowledge, how are you going to evaluate data quality? Also, because in a company like us with several business lines, the level of maturity of different business products is different. It's not the same flights in eDreams that insurance or a new product that we're testing. The requirements of data quality are not at all the same. And what about releases? Because if you want to enforce the data governance, it means what? That the data team can block a release because data is wrong? If you do that, then forget about the 60 releases per day and forget about your 400 developers working in parallel. But if they cannot block the release, how can they be made accountable for data quality if releases happen and they just realize whatever? We didn't really understand how we could make the data lake work. Which brings me to the third and final part of the talk, which is the data mesh and how we think, I will explain here what is it and how we implemented it and how we are now think that this will solve these problems and creates a different set of problems, of course. So in 2019, when we're reviewing this, we follow several people. One of them is Martin Fowler, and in the blog of Martin Fowler, a person called Zamak Degani from ThoughtWorks published this entry about data mesh, which is a short article with no details of implementation, but with a different paradigm, a different set of principles to resolve this problem. And basically, a data mesh looks like a data lake, but it's very different, and it's based on 3 different principles. The first one is that you have to embrace that you have to have a distributed architecture aligned with your domains. You cannot have a central thing, just that it. It also said that domain events were a very nice way of representing facts that happen in the business, and it said that it had to be the teams that were accountable for the data that they were pushing, that were creating, not a central data team. It also said that you cannot treat data as an afterthought, that data is part of the product that you're building, so it needs to be prioritized along with the features, along with the bugs. Teams need to think about data the same way that they think about other features, other aspects like performance or reliability. That a team needs to establish service level objectives, SLAs regarding data the same way they do it with response time or the quality of the service. And the third one is that yes, for efficiency, you will want to have a generic infrastructure for data, but it needs to be first self-service, so people can use it without having to synchronize with the centralized team. And second, that the way to achieve this is by having the infrastructure and the data team completely domain agnostic. So the pieces that you build for the data pipeline cannot know anything about your business. They need to work regardless of this. And of course, it didn't mention how you accomplish any of these things in detail. It did enough so you believe that this was possible to do, and we liked it very much because, unlike the data lake, this matched our set of problems. Because yes, we had domains, we had autonomous teams, we had independent releases, we had the goal of increasing the autonomy of all the teams. It was designed for microservices. It was thinking about the microservice world and the analytical world. It was talking about domain events, which we already liked, and it offered a way to design the data infrastructure that would allow us to have efficiency, because only one team will take care of that without blocking the releases of everybody because of this. So then, in 2019, we tried to implement this. And of course, because we actually needed implementation, we had to add principles and decisions to the general article. And this is a summary of the things that we decided to do. I think that now that years have passed and we have seen other people doing this, none of them are really strange or weird. But time will tell because this is a new area. The first one is that data as a product is a super nice thing to say on paper, but it's the most challenging thing to accomplish. How do you really manage that the team feels that data is something that they own and they have to care as much as features and bugs? We did three things. First, the data governance. We always try to enforce it with automation, not with rules, not with processes, not with checklists, but the system, the code, the automation enforces data quality. Second, we try to foster feedback loops. The best way to ensure that the team cares about the data that they sharing with the other teams is by having that same team use the data that they're sharing. Because if they use the data that they're sharing for their own reasons, they will surely take care about the data. And the third is, as I said before, always favor that every time there's a choice between the cost of something being on the consumers or on the producers, it's on the consumers. You want to make life super easy for people producing data at the cost of making life a bit harder for the consumers. The second thing is that we wanted that in terms of the cost of the money that you spend on the infrastructure, the ones paying for the queries were the consumers and not the producers. At the end, it's the same company that pays for everything. But in our experience in the past, we had this problem that a team is responsible for a system that shares data with other teams. But how do you budget this? How do you ask for money for next year? You don't know, because part of the cost is how many queries that you're getting. And this always creates tension between the owners and the consumers, because they want to use more data, but there's no money. So we wanted our system to be able to differentiate between the cost of storage and the cost of querying. I wanted the cost of querying to be something that we could say, this consumer is using this amount of money, this other consumer is using this other amount of money. Because that's crucial for having self-service consumption. And the third one is that we want the data mesh to encompass the whole data of the company. So how do we do it? Do we start by designing upfront the whole data model of the company? We decided that was not a good idea. Instead, we said we're going to do this in iterations, and we're going to put a rule, which is we will never add a data set to data mesh unless there's an actual consumer that is going to use it. If there's no use case, we don't do it, even if it's easy to do. This means that we didn't do an upfront data model, and what we did instead was using the use cases to refine our design rules to model the domain events and the snapshots. And in the plan that we did, we embraced the fact that data is harder to handle that code, because code, you fix it and that's it. Data, you cannot, when you have terabytes of data, you cannot do upgrades of versions of terabytes of data. So in the governance system that we do for designing the domain events and snapshots, we use the same governance rules that we use for APIs, but a bit stronger, a bit more strict, because data is more difficult than code. And the third one is that in the plan, we assume that the first use cases will be harder than the second use cases, because we'll be learning in the process, and that we could have the problem of after the third or fourth use case, realizing that there was something wrong with the system and have to go back and redo all of them. So how does the architecture of the system look like now? Well, you have microservices, publishing and consuming domain events and snapshots to Apache Kafka. Then you have a dedicated system that reads all those domain events and snapshots from Kafka and writes to BigQuery automatically. It creates the tables for the events and writes them. Also, there's because you're in Google Cloud, we have for free one thing which is called the Google Data Catalog, which is a system of Google that allows you to write there the schemas and the documentation of all the domain events and snapshots. So analysts can go to the data catalog, to the UI, this has a nice web UI, and search, do a text search, and the system will tell all the events that match the text, will show documentation, and will show metadata, like, for instance, what service is publishing this data, and therefore who owns the data. And of course, BigQuery, we chose BigQuery because it's a cloud-native data warehouse. It allows you to do queries of terabytes of data in a few seconds. It's super performant. You can query with standard SQL. It supports Avro, which is super nice, and has this nice feature that you can actually attribute cost to queries. In BigQuery, the cost of storage is different from the cost of querying, and you can know who did each query, so you can build different teams, their build of the queries that they make. And it allows you to have access controls defined by column and table, which for us is a must because we need to comply with privacy and financial regulations. The challenge here was that, if you remember, one of the principles was that the data infrastructure needs to be domain agnostic. So this mesh loader here cannot know anything about the domain events themselves, and it needs to be self-service, which means that when you add new domain events, you shouldn't need to change the service. So how did we make this? Basically, what we did is that we have a repository in the system with all the definitions of all the domain events as YAML files. This repository is version controlled with Git. You have one YAML file per event, and when a team wants to has the definition of a domain event, they can just write it and do a pull request, and then it gets approved. When that happens, and the YAML file has the metadata like the service that is publishing this, the definition of what personal private information it has, so we can implement access controls and financial information, or things like how do you partition data. With this, we have traceability, we can comply with GDPR and PCI, and we can automatically create the tables, because the service, actually, the mesh loader, can, every time it finds a new event in the Kafka queue in real time, can check the YAML file if it doesn't know it the first time it sees, and can automatically create all the columns, create a new table, create all the columns, and implement all the access controls, because all this information is in the YAML file. Just to finalize, I will give a few examples of how looks data governance automated look like. One example is about data loss. One of the normal problems with data pipelines is that you have bugs, and sometimes data is lost. And a big problem when you have this is that when data is lost in the pipeline, it can be because of two things. Maybe there's a problem with the data pipeline, the infrastructure, that it's losing data, or maybe the service that is publishing data has a bug and it's not publishing the data. And a big problem is that when you realize you have a data loss, usually the team that owns the infrastructure says everything is working fine. It has to be the service. And the people that own the service says, no, the service is working super fine. This has to be a problem with infrastructure. I'm not going to spend my time researching a bug in my code until you guarantee that it's not a problem with the other guy. And this is difficult to get out of this loop. So it's a real case scenario. I've been called as an arbiter in these kind of situations. So we implemented something which is a domain agnostic service that in BigQuery you don't have foreign keys, but conceptually you do have foreign keys. We do have foreign keys. So what we do is, okay, if you know that you have a foreign key in a different domain event of a primary key here, I can do a query that checks how many foreign keys do not exist as primary keys. And when that happens, usually what happens is that there are primary keys being lost. It's not foreign keys being made out. That's a really rare bug. So we can query this, and we can have numbers, and we can run this query periodically. And the team that is the owner of the domain event can have a context saying, okay, I'm going to guarantee you that I am going to have no more than 0.1% of data loss. So the system can query this periodically and can alert when this level of errors is broken. It also does write all these things. So if I'm an analyst and I do a query and I want to know, hey, but 1 month ago was this working okay? I can go to a table in the data mesh where this is written and check if during that month the SLA was held or not. And also helps with the problem of fixing bugs, because with this, when there's a data loss in some place, if it's an infrastructure problem, it's not going to happen only in one domain event. It's going to happen in all of them. But if the problem is in the code, it will happen in one domain event and not in others. So this allows us to ease this kind of conversations. Another examples are, as I said, we try to foster feedback loops. So production of data consuming the things that they produce. And we are adding features to the system to try to incentivize people to be consumers of their own data. One thing that we implemented was, one big advantage of the data mesh is that you can query, and you can query data for the whole platform. You can cross your data with data from other systems. So usually when you want to monitor business KPIs, it's not enough with your own system. You need to do queries with others. So one thing that teams can do is that if they can write a KPI with a SQL query in the data mesh, they can do a pull request to this system, where they configure the query and the periodicity. And then the system will regularly query the data mesh with this query and push the result as a metric in Datadog, which is our APM system. And then in Datadog, the team can define alerts, can define dashboards, can define whatever they want. Another way that we try to enforce this is that BigQuery is at the end SQL. In Google Cloud, we have a free reporting system, which is Data Studio, that now Google has renamed to I don't know what, but it's free. So teams can now, they don't need to rely on BI to create dashboards and reports. They can write their own with the data that they have and linking that with data from any other system on the platform. And now with this I finish. Things that we're doing now, we are implementing automatic versioning control enforcement with Kafka registry that allows you to put versioning in your events and enforce that people do not break contracts backward. You can enforce backward compatibility and forward compatibility. We're going to research using the Debezium for CDC, because then the navigation of foreign keys can be automated in some cases. We want to integrate data from third parties, which mean not only the platform, and we want to implement more feedback loops. And if you found this talk interesting, there's two feature work for you that I can recommend. First, there's a book that the author of the blog entry wrote, and was published a few months ago. And second, there's a very good article on data dichotomy, on microservices and data by Ben Stopford in the Confluent blog. And with this, I'm open to questions. I hope you found this interesting. Thank you.
Any questions?
Yes.
Just to understand your context, you have only Java microservice, or have also other kind of languages in more than 2,000 microservices?
Mostly, all our backend microservices are in Java.
Okay.
We have one in Groovy, but we also publish domain events from the browser and from the native apps. So we actually have JavaScript, Swift, and Kotlin.
Okay, but all your producer of data are mostly in Java?
No.
No.
The native apps also produce domain events,
Okay.
and the browser also produces domain
Okay,
events.
they
They have separate data pipelines. Yeah.
Okay, so is how was hard to you to implement the same pattern on different platform?
Well, it's tricky, but it's doable. There are things like, for instance, timestamps that are tricky, because in the backend you can rely on your clock. In the mobile phone, also in general, I say in the browser, no. So you need to have two timestamps, for instance. There's also the technical thing of how you push data from the browser to the backend, and you have to accept that sometimes data is incomplete. But in general, it's quite doable. Yes. And with the mesh, we have this big advantage that we didn't have in the past, because there are systems that track, monitor web activity. And we have them, and we have actually more than one. But it was always impossible or very difficult. You had to do a lot of work if you wanted to cross-reference the data from the web with the data from the backend. These were in practice silos. Now with the mesh, for the first time, we can actually do a query that joins data from the browser with the backend, and this opens lots of possibilities, and it's a super nice feature. I haven't got here in the details of how you transition from all this. I mean, how do you now? In eDreams you have the mesh, but we have not retired the silos. All this is living together. So there's another challenge, which is how do you transition all the silos to the mesh without disrupting everybody. One of the ways, the incentives of people to abandon the silos and go to the mesh is the ability to do this kind of cross-referencing of data in the whole platform.
Thank you.
That's answer.
Yeah.
So if I've understood correctly, in your BigQuery database, you basically have like one table for each entity or event or something like that.
We have one table for each domain event and one table for each snapshot.
Okay, but does that mean that you have like a kind of a generic data model? So
No. Every time a team wants to have a domain event, they will model it. We have a governance process to make sure that the modeling, the design of this is consistent with everything. As I said, it's very similar. We use the governance process that we have for APIs of microservices, only a bit more strict. Then they will develop it. They will use libraries. The effort is usually, the development effort is a few hours, no more. They will do a pull request to register the YAML, the schema in the repository, and then automatically the system creates the table and starts writing to BigQuery.
Okay, this means basically that the data model is driven by the producer in some way.
Yeah, and
there is a governance
process. No one has got into a room and designed the data model for the whole company, because this was one of the problems with the data lake, because who is going to do this? And second, we do 60 releases per day. By the time you finish your data model, it's already updated. How can you how can you model? I mean, it's not possible unless you freeze everybody. But this, I mean, I will get fired immediately if I went to my boss and said, releases have to stop for, I don't know. Yeah. Okay. We have not done this. Instead, the challenge here is that you need to have rules for designing the domain events and snapshots, so that by adding things incrementally, the whole thing is always consistent and makes sense. This is the challenge, really. The rules to design this.
Real question is, from the consumer point of view, am I referring to machine learning, whatever you are doing with the complex data? Is this kind of data organizing enough, or people is starting doing replicas, doing materialized view, whatever it is, because they need to do complex joins or stuff like that?
Because it's an excellent question.
My feeling is that the data is still siloed in a way. It's just in one big record that scales.
One of the rules that we have is that when we model this, we always make sure that there are foreign keys to other things. So data is interoperable. This is the first thing. Second thing is that I didn't get into that, but we also have the concept. We have 3 data products, let's say, domain events, snapshot, and views. Because sometimes one problem with domain events is that you have to do lots of joins, and this is common with many teams. So when this happens, we are allowed 2 options. You can do the views in your BigQuery schema, fine. But if that view is not only about you but other teams, it's fine if we define the view and we put it in the mesh also. But then it has to have an owner. There's a process here. And there's a bigger problem actually with all this, which is that in terms of the biggest challenge, I think. Yeah, consumers complain about the joins. They're not happy about it. It's with the snapshots they're happier. But there's a bigger challenge, which is if you're an analyst, yes, you will document everything, but what does it mean to document? Because the rule that we have is that the documentation that you have in an event is targeted to somebody that knows about that domain. So if you go to the fraud domain events, the people that write the documentation assume that the reader knows about the fraud in eDreams. The documentation is not explaining how fraud works in eDreams. And this is a common debate within the company, because sometimes people say, hey, but I don't understand this. Well, you don't understand this, but this is not a problem of documentation of the data. It's a problem that domains are complex, and this is not possible to do in the documentation of the data. You need a separate channel. You need to understand how fraud works, or flights, or hotels, or whatever, and then you will be able to understand the data. But this dream, because if you are in this area, there's lots of marketing information about data catalogs and lots of debates on whether they're useful or not. I think they're very useful as long as you do not pretend that I, that know nothing about how hotel works in eDreams, will go to the data catalog and be able to do queries about hotels. That's impossible if I don't have the domain knowledge, and that is not in the data catalog. That's not what. And I think that's the biggest challenge for analysts.
Because basically, data catalog is a technical stuff.
No, it's domain. It's domain. If I know how a domain in eDreams works, the documentation of the data in that domain, I should be able to read it. If not, the documentation is wrong, and we need to change it. But that's the deal. It's not about I'm an analyst, I'm curious, I want to do thing in another domain that I don't know, I go to the data catalog, and now I can do it. No, it will not happen because you have no clue on how the other domain works, and that's not the role of the data catalog for us. Yes, and also for developers usually, as far as I know, and they will correct me, they don't use the data catalog, because for them, when they want to data, they know what service it's read the data, so they go directly to the Bitbucket repository and they read the documentation directly, or they contact the developer directly, whichever is faster.
Thank you.
You can correct me. We have here users, so you can contact me whenever you want.
Thank you.
What else?
Any questions?
I think you've made all this stuff custom made because you are really big. But I'm wondering if there is some way, some open source code or stuff like that to start.
Not that I know of.
Okay.
I wish, because remember that we started this. I think a few weeks, 1 month after the blog entry was published. So when we started doing it, there was nothing. As far as I know, and I think that if you Google now data mesh, there's lots of hype around data mesh, and there's hype, and there's also people completely against it. There's how a divide. And I think that there are some companies that are starting doing things around it, and I'm sure that in a few years, if this goes well, there will be something. But today, as far as I know, no. We use lots of open source things here, but these pieces that we mix, like the Kafka registry, the libraries to generate the code from the our schemas, but there's no data mesh, right? As far as I know, but I hope that one of these days when I talk about this shit, somebody will say, hey, but why are you not using this? And I will say, because I had no clue, but now I have. So far it hasn't happened.
So it's time to get it on GitHub, to upload all this stuff on GitHub.
Yes.
To start.
Yeah, it would be in our case that would be super very nice thing. The problem is that all the things that we have done, they're custom made for us.
Okay.
So if we push them to GitHub, I think that it looks easy, but to do something generic for everybody, it's a different kind of problem.
But you think that in a few years it will be a
I'm
commodity?
sure that with the amount of hype, because when we tried when we started selling this to the company, to the executives, we were honest. Say, hey, this is a blog entry in a reputable size, but this can go very wrong because nobody has ever done it, and we may fuck up this, I mean, royally. So beware. But now, 3 years later, there's lots. I mean, Google has articles talking about this. It's all around. There are big companies doing, big consultants that did data lake now. They would let you do data lake. So I think that this goes on. For sure, something will happen in the open source community. Somebody will do it.
Okay, thank you.
I'm hoping it happens, because the moment it does, we will try to get rid of our own code and use the open source and stop. We have other things to do. But yes.
It's a good topic for an hackathon.
Yeah.
Questions? No? Matt, you want to wrap up?
Okay, so no, from I was checking the YouTube. No question from the audience. So just Carlos, thank you so much again.
Thank you for having me.
A big round of applause.
Thank you very much.
Really appreciated. Grazie a te. Really appreciated the talk. Really appreciated also again Dreams ODGO for hosting Jug Milano. Just a couple of logistic points for those following with the live streams. There is the link in the chat to do the raffle for the IntelliJ license. For everybody who is here in presence in the Jug Milano mailing list, there is a link, so you can use that and get a chance to raffle that. Now we're going to have a little happy hour here. Too bad we cannot do it over the stream on YouTube when the metaverse will come eventually, maybe, I don't know. As you're going there, don't forget, if you didn't register with the QR code, please do so, but I saw that all of you did it, so thank you for doing so. And also as well, we have more goodies actually. We have a bag of little goodies there that with another QR code. You can scan and get it, so don't be shy. We'll be just over there. And again, so if you have any topic to speak about at Jug Milano, please feel free to reach out to us. We will be happy to host you. The next Jug, where is Vasco? The next Jug Milano is Vasco. You don't see it; it's just off the camera. So in the month of March, as always, subscribe to the mailing list and the YouTube channel to keep updated. And with that, thanks again for the present. Thanks again to our speaker and to our host.